Dun, 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 dun. Hey, 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 hey. Mr. Warrior. Hola. It's another math video, my friends. Oh my goodness, look at the snakes. Woohoo! I like my reptiles. It says here that we're going to be solving problems involving fraction division. In this video that I'm going to do today, it may be long. You're going to have to hang in there. As it will be covering a lot of material. This video is more of a review over many of the lessons prior on Eureka, Module 4. This is Lesson 27. So we're going to go ahead and review our key strategies for problem solving with our good buddy, Mr. Snake. Yeah. Okay. Anyway, it says, first of all, model the problem. Okay. Can you draw something? What can you draw? What conclusions can you make from your drawing? We've been doing a lot of modeling with mathematics and clearly making sure that we visualize what we understand, because that is one of the biggest keys in math. Oop, this guy's trying to come over here. Go back. Okay. Now we have calculate to solve and write a statement. Calculating the planning that goes involved when we're doing that. It's important that you guys get a chance to solve the problem and then making some kind of statement of your understanding, the solution. And of course, we always assess the solution for reasonableness. You hear me use that word a lot in my videos because it's really important that when we come to a solution that we don't just say, hey, I think it's right, I'm pretty sure. No, we actually ask ourselves, does that answer seem reasonable based on what I'm trying to find out? And you're doing another steak there. Problem 1, we have Mrs. Silverstein bought 3 mini cakes for a birthday party. It says that she cuts each cake into quarters and plans to serve each guest 1/4 of a cake. How many guests can she serve with all of her cakes? We're going to go ahead and draw a model to support your response. Okay, so again, I'm always going to go back to, you're going to see me write this many times, and that's that read for understanding, draw, and then of course the write, which is the statement, much of what we just covered. So making sure I have a good understanding. I understand that she has these 3 mini cakes. This is acting as the dividend. She's going to be cutting the cake into quarters. That suggests that's going to be the divisor because that's the group size. And then we're going to try to find out if 1/4 is given to each guest, how many guests could she serve with all of these cakes? And so what I see here, my understanding is we have a whole part, and that whole I think of is those are the 3 mini cakes. We have the 3 mini cakes, and she's going to create quarters. Okay, we can think of that as maybe taking a line here, and I'm going to make thirds here. There you go, something like that. That represents, of course, each cake, and now I want to make some quarters, so I'm going to split this one in half, and there's my last quarter. And I've only drawn right now at this point what we're understanding from the problem. Some definitely important points I want to go ahead and write down. First of all, is I can see that there's 4 fourths, okay, in each hole. That lets me know then if I were to take, since I have 3 holes, I can say 3 times 4, okay, is going to equal 12 then, 12 fourths. And our problem in the division equation, I can see is 3 divided by our quarter. And based on our model, I can see that the answer is going to be 12. And I can also double check my work by saying, well, 12 times then that 1/4 should get me back to my whole, my dividend. And in this case, yes, if we were to multiply that, we would have 12 over 4. And of course, 12 divided by 4 is 3. And there's our 3 mini cakes. So now my statement that I must write, which I believe I have prepared, might look like this. Okay, then Miss Silverstein can serve 12 guests 1/4 of a cake. Okay, okie dokie. Let's go on to another problem. Another word problem. Problem 2. Hey, it looks like Garfield in some lasagna. By the way, my favorite food, lasagna. Love it. All right. It says Mr. Pham has 1/4 pan of lasagna left in the refrigerator. He wants to cut the lasagna into equal slices so he can have it for dinner for 3 nights. How much lasagna will he eat each night? Draw a picture to support your response. And of course, all of these questions, important about drawing the picture. I'll bring down, so here's my little board here. So again, I'm looking at it, my reading, I'm understanding that there's how much lasagna there is. That's all there is, 1/4 pan. And then I see that he wants to basically create those equal groups, so he's spreading it out over 3 nights. That lets me know right away that I can get my dividend. So I'm going to go ahead and bring my tape diagram out again. And with my tape diagram, I can show my quarter. However, I'm going to do something like what I've done in a previous video, which is rather than trying to label this whole thing as a quarter, we're just going to go ahead and just call this whole thing as if it were just one whole pan of lasagna. By doing that whole number, this is going to help us out when we break it up into fractions. If that's the quarter, then that would mean that this would roughly be the halfway. Okay, so this is the half, and we need to get a quarter. So I'm going to take another one of these. Okay, so here I'm just showing, this is the shade is showing the 1/4 amount of the lasagna. I see our division expression as our 1/4 divided by those 3. If this is 1/4 and this is the whole pan, I need to actually divide this into those 3 nights, because none of this is lasagna. This is the rest of the pan, but there's only that 1/4 pan. Here I have my third, so I've created my 3 nights, first night, second night, third night. So I want to show you here, this is our 1/12 now. And we have 1/12 because if we have 3 here, we took this one whole, we divided into quarters. Here's our 1/4, 2/4, 3/4, 4/4. So if there's 3/12, or I should just say 3 here, 3 times, this is our unit here, 3 units here, and we have 4 of those units, means that we end up with 12. And here, we just think of it as 12. 12, I think that's spelled right. Don't hold me to that. And so that's what we have here, and here's our 1/12 showing, and this is how much each person would get. So our answer here is going to be 1/12. 1/4 divided by 3 is equal to 1/12. Now the rest of this shows the 12ths, and I've just extended that here, and the dotted lines indicates that's not something that we used as part of the problem other than to just show the whole, and this is how we're breaking it down. Well, finally, we would have our written statement that we'd want to put. So basically, Mr. Pham will eat 1/12 of the lasagna each night for 3 nights, which would be 3/12 here over the course. So 3/12 is equal to 1/4. Perfect. Let's go on. Now it says here we have problem 3 says the perimeter of a square is 1/5 meter. Okay, it says first we have to find the length of each side in meters. We have to draw a picture to support our response here. And then it says how long is each side in centimeters. It looks like we're going to be doing some metric conversion here from meters to centimeters to answer all that's been asked. What do we understand? Well, we understand that the perimeter is 1/5 meter. That's helpful. It doesn't give us the each side length in meters. So it's this one side here that I don't know what the measurement is, and that's what we need to find out. Well, let's think about some things that we do know. Okay, we know that the perimeter of the square is 1/5 meter. So that's something that's important. That's going to help us. Now, rather than again going and writing 1/5 meter as a whole, let's go ahead and just do 1 meter. There I have my five pieces. So that's 1/5 meter, 2/5 meter, 3/5 meter, 4/5, 5/5 meter is the same as equal to 1 whole, right? 1 meter. So I've shown that on the drawing. Now I'm going to go ahead and shade in my 1/5 meter. Right, now I have my 1/5 shown here. I'm going to go ahead and mark that. Our division expression would be 1/5, right, divided by 4. Okay, so let's summarize again what we have here. We have that perimeter of 1/5 meter around the square is the perimeter. That means it's each side is going to be 1/4 of that 5th, because we have 4 sides to this square. So I'm going to go ahead and I'm going to break that up into fours. See, I have this in fourths, so my 1/5 now has been divided into fourth because this entire perimeter is 1/5, so each side is going to be 1/4 of that 1/5. So I've taken that 1/5 and divided by 4 as my division expression equation says here. Well, if there's 4 parts in 1/5, then how many parts would there be in 5/5? You see, we're doing a little bit of multiplication here. So let's do some multiplication here. If there's 4 and there's 5 parts, aren't we taking 4 times the 5? So we end up with 20. That means each one is a 20th. 1/20th of a meter. This is where this makes it really handy having that. So we're going to end up with 1/20th over here. And keep in mind not to be confused, but this is the part we created that shows the quarters we created within the problem here. We didn't use this space. We only shaded this because this is the 1/5 of that amount. Therefore, one side of this square will be 1/20th of a meter. I'm going to go ahead and write that. So here we have the length of each side is 1/20th of a meter. Now if we took 1/20th, checked our work, we could take 1/20th times 5. So we can check our work by taking our 1/20th times the 4 sides, which is 4 over 20, which is going to equal 1/5. And that does, it gets us back to our dividend, the amount of the perimeter going all the way around. Now it says how long is each side in centimeters? So conversion, we need to know some information. We usually only have to deal with a few. Centimeters is 1. There's 100 centimeters in 1 meter. Okay, there's 1,000 millimeters in 1 meter. Okay, there's 1,000 meters in 1 kilometer. These are the commonly used measurements. Well, if we have this in meters, we need to convert it into centimeters. How do we do that? To go from meters to centimeters, look at the difference. We have a power of 2 tens. So we're going to need to multiply the meters by 100. So let's take 1/20th. That's one side. We're going to multiply that by 100. Again, that's just 100 over 20. And now we have a power of 10 here, which is really, this is just 10 divided by 2. So this is just going to be 5 centimeters. Not a really long side. Okay, so that's going to, so each side, and I'll write this down, will equal, or each side is 5 centimeters. Oh my goodness, there's an A and B. We have an A and B here. Problem 4 says there's a pallet holding 5 identical crates, weighs a quarter ton. How many tons does each crate weigh? Draw a picture to show you, to support your response. And again, how many pounds does each crate weigh? And they're going to have us again do this conversion from tons to pounds. So we'll need to know how many pounds are in a ton. Go ahead and it says to draw a picture to show. Well, again, we don't have a whole number here. This is my dividend though. This is what's being divided. Because if the pallet, there's a pallet that holds 5 identical crates, there's 5 crates on one pallet. But the whole thing weighs a quarter ton. So I'm taking that 1/4 ton, which is my dividend. This is the size of the group here, 5, to determine how much each crate weighs. We don't want to use our quarter ton. We've been doing the whole ton. Let's do the 1 whole. That will make things much easier later, as we've learned. And because this is a quarter ton, we're going to need this. Okay, I've split this into quarters. Now I can show my 1/4 ton here. Now I've shaded in my 1/4. So we had that 1 ton. Okay, I'm just showing this down here. We're not dealing with any of this here. All right, this is the other 3/4 tons, which we don't need. And this is just to show that we have broken them up into 5 because we need 5 identical. So I'm going to go ahead and show that with this. Okay, this shows the 5 crates in that 1/4 ton. And we're trying to determine what the weight is for 1 crate. So I'm going to go ahead and mark that, this little spot right here. Well, what is that amount? Well, if we have 5 in 1/4 ton, that means we would have 5 times the 4, which again equals, in this case, 20. Like we just did this on the previous problem, yes? So we have 5 times 4, which equals 20. Therefore, this quantity here is going to equal 1/20th. Here, the 1/4, because that's a quarter, that the 1/4 is equal to 5/20ths. Okay, and this is what we're basically learning. So each one of those is 1/20th. So each crate is going to weigh 1/20th ton. And this is our statement showing our understanding here. A lot of it. We could check our work, which we always do. Remember, the quotient multiplied by the divisor, going back to our 5. I'm sorry, we didn't even write our division statement. It should have been 1/4 divided by 5. We never did get that down. So now our 1/20th multiplied by 5 is 5/20, or in this case, 1/4 ton. How many pounds does each crate weigh? I'm almost positive there are 2,000 pounds and a quarter ton. So in this case, we're taking 1/20th of a ton, and we're going to multiply that by, since there's 2,000 pounds in each ton, we're going to determine how much weight that is. So if we have the 1 times 2,000 up here, and then that's going to have the 20 down below. Now here's some common factors here. I see a common factor of a 10. So if I were to, even with a 2, well, to make this even better, if I were to divide a 20 out of 2,000, I could actually divide a 20 out. So 20 divided by 20 is 1. So that leaves nothing here. And if we divide a 20 out of the 2,000, you'll see that that's going to be 100, because 100 times 20 is 2,000. So we end up with an answer of, that's it, 100 pounds. And that can be written like this as well. So our statement here is that, yeah, each crate weighs 100 pounds. We just put that right here. All right, making good progress. Let's keep it going. Okay, here we go. Problem 5. It says Faye has 5 pieces of ribbon, each 1 yard long. She cuts each ribbon into 6. Okay, how many 6 will she have after cutting all the ribbons? It says, how long will each of the 6 be in inches? Okay, take a look at this and how I'm going to attack this. I think I might want to really make sure that I use my read, draw, and write. Really focus on the reading here. So 5 pieces of ribbon, each 1 yard long. Okay, so we have 5 yards. I'm trying to get a better understanding here. She cuts each ribbon into 6. Okay, so I think rather than me trying to make some kind of hole as my 5, I like the 1 yard unit here. I think what I would do to solve this problem is I would do this. I think I would go ahead and show this as my 1 yard. I am going to divide it into 6, so I'm going to go ahead and, wrong one, dotted line here. Okay, so this is going to go right in the middle. And let me do the rest of them. Okay, so I have my 6 here. So I've taken one of the ribbons here and cut them into 6. So now my problem, my division statement will say 1 whole here divided by, and we're trying to figure out what is in the value of 1/6, because we have 6 equal pieces here. Well, there's 6/6 in 1 yard. Okay, so that's definitely in 1 yard. And that would mean then there would be how many 6, and I'm just writing this down, so do you think, in 5 yards. And I'm going to abbreviate that. Well, yeah, 6 times, there's 5 of them, then that means there's going to be 30. So there's 36 in 5 yards. So Faye will have 36 after cutting all the ribbons. Let me go ahead and write that. So let's put that down. Faye will have 36 after cutting all the ribbons. And we're not quite done, because there is a part B. And the part B says, how long will each of the 6 be in inches? This is based on yards. And we know that there is 6/6 in 1 yard. So 1 whole divided into 6, 1/6, that would mean that this would equal 6. Can we check our work? 6 times, right, our 1/6 is 6/6, which is equal to 1. And it gets us back. And we determine that 6/6 in 1 yard in this 1 whole. And then we multiplied. Now we need to convert into inches. Well, again, this unit you have to have pretty much memorized. Most people know there's 12 inches in 1 foot. There's 3 feet in 1 yard. We could just go straight to how many inches are there in a yard. 1/6 of a yard times 36 inches. And 36 inches, then that's going to be 36 over 6. And you can see we have a common, right, factor, which is just 36 divided by 6. So we end up with 6 inches. Now, does that seem reasonable? Well, in 5 yards, 36 times 5 is going to be 30, 15. That's 180 inches. So if we had 6 inches in 1, we could take the 6 inches times 30. 6 times 30 is 180 inches. So our numbers match up, so we are good to go. A glass pitcher is filled with water. Okay, straightforward. 1/8 of the water is poured equally into 2 glasses. So we don't know how much water is in the pitcher, do we? We don't. All we know is that 1/8 of the water is poured equally into 2 glasses. So first thing is what fraction of the water is in each glass? This is kind of like our step 1. Well, if we have 1/8 of the water is poured equally into 2 glasses, what we're saying is this is kind of like our dividend. 1/8 of the water, we have 1/8, whatever that amount of water is poured equally into 2 glasses. If we were to take, we could say that since there's 2 glasses, let's say that 1/8 is going to get split in 2. So if we have, here I said I wasn't going to draw a picture, but just kind of think, here's your glass and you have another one here. Okay, so that 1/8 is going to be split where some of it's going to come in this one and then some is going to come in the other. So this is basically what we're saying is we need to find out what 1/2 is then of the 1/8 of water. And that's pretty simple, right? 1/16. So 1/16 of the water will go into each glass. So 1/16 of the water will, let's say 1/16 of the water is, let's try it this way, is in each glass. That's as if each glass has 3 fluid ounces of water in it. How many fluid ounces of water were in the full pitcher? If 3 fluid ounces of water is in each glass right now, that would mean that 1/16, because that's what the fraction was, that means that 1/16 is equal to 3 ounces. See that? And that also means then, since there were 2 glasses, with the 2 glasses together, that would mean that 1/8, because we have 3 ounces, times the 2 glasses in each, we end up with 6 ounces. And that means that in our unit here of 1/8, that 1/8 of the water from that pitcher is equal to 6 ounces. Now, that's our 1 unit. Well, how many more eighths would we need to make that whole? We'd need 7 more eighths, right? So we could take the 6 ounces then, and we could multiply that 6 ounces with the number of units we have, which is 8. Now we end up with 48 ounces. So 6 ounces by the 8 units is 48 ounces. So we can say there are 48 fluid ounces in the full pitcher. And let's write that down. There are 48 fluid ounces in the full pitcher. Great, and we still have another problem. Now it says if 1/4 of the remaining water is poured out of the pitcher to water a plant, how many cups of water are left in the pitcher? So could we show it this way? The whole pitcher itself would have 48 fluid ounces in there. We determined that 6 ounces were removed. So we could say that in the pitcher right now is 48 ounces minus those 6 ounces that were put into the 2 glasses. Now we have 42 ounces. All right, I hope I have everybody with me. And what we're trying to find out is if 1/4 of the remaining water is poured out, if 1/4 of the remaining water is poured out of the pitcher to water a plant, how many cups of water are left in the pitcher? Well, let's just figure out ounces right now. Let's not worry about the cups. That's another unit. So 1/4 of the remaining is poured out. So what's left in the actual pitcher? That would mean 3/4 would be. 3/4 of 42. Did that make sense? So 3/4 of 42, of course, means 3/4 times 42 ounces over 4. We probably have some common factors here. What do we have here? 4, 42, 12, 11, 10. And divide that by 2 and we get 2. Divide that by 2 and we get 21. Now we have 21 times 3, which is 63. We have that over 2. Then we can rewrite that as a mixed number, and that would be, what, 31. And then we're going to have 1 left over, and then we have our 2. That's what's going to get left inside the pitcher. We need to change this into cups. Well, we need to know how many ounces are in a cup. Last I checked, I believe it was 8. So we have 31.5 ounces. I'll just put OZ is equal to, and we're trying to figure out how many cups. Basically what our goal is here. Here, if there's 8 ounces in each cup, we could rewrite this problem as 31.5 ounces, okay? Multiply it by 1 over 8 because there's 8 ounces. And it's kind of a way of dividing here. This would be for the cups. And then this will let us know how many cups will end up in the end. This is just converting the ounces to cups. Now, we could multiply, use the distributive property, 31 times 1/8, and then also multiply the 1/2 part with the 1/8, and that would equal, again, so many cups. Now we have 31 over 8, and then we're going to have plus, and this is going to be 1/16, and again, this is going to give us our ultimate answer. So this will be 62 over 16. If we get that common denominator, plus 1/16 is going to equal 63 over 16, and that's going to equal, if we divide that, no, we're looking at 8, 16 is going to go into 3 times, let me see, 48, and 63 minus 48 is be 15 over 16 cups. Now, that might have been pretty challenging for a 5th grader anyway. Trying to think if there'd be an easier way. So I wonder if there's an easier way to show this. If there's 8 ounces in 1 cup, then we would want to take the 31 and divide it by 8, which we can't quite do. What could we do? We could find a number that's close. 32 is close. That would be 1 additional ounce. But what if we went backwards, like 24 would be the closest? So let's take 24 divided by 8. Remember, 24 ounces would divide by 8 because there's 8 ounces in 1 cup. That's 3 cups. And we still have 7 ounces left over. Okay, we have 7 ounces left over and a half. Almost enough. Now, this is almost 8, so we have 7.5 ounces. We need to know how many cups that's going to make. We have 3 full cups. If we just had a half ounce more. Looking at that, how could I convert that? 7.5 ounces into cups? Tough. We would end up having to do something like taking 14, making that 15 halves. And 15 halves is how many ounces we have. And we'd want to divide that by 8. Yeah, this is going to be tough because we haven't done this before. And it's going to equal a certain amount. Okay, I think this may be a little bit challenging here. There's a lot of steps here involved. I mean, if we didn't have a mixed number, the number is a little bit friendlier. Obviously, 32 would have been a better number. It would have given us exactly 4 cups, but they made the problem a little bit more challenging. What can I say? It's Eureka. Again, I have to say, it has come to an end. We have completed all the problems. There are no more. So, my friends, now, live long and prosper.